Cool. Awesome. Well, welcome everyone. Thanks for joining our virtual tour. My name's Katie, and I'm currently a fifth year student studying biomedical engineering with chemical and biological engineering. And yeah, I'm excited to have y'all here. And if you have any questions throughout the tour, you can feel free to unmute yourself or you can send them in the chat. And at the end, we'll make sure to leave plenty of time to answer any questions y'all have.
Hi, everybody. My name's Ethan, but most people around campus call me Goose. It's a whole story. I'm a fourth year. Sorry. Fourth year studying biomedical and mechanical engineering with a pre-med focus. Aside from being an engineering student ambassador, I'm involved on-campus research and hopefully soon getting back into volunteering at the hospital when I have some free time.
Thanks. Okay, let me know if you can see my presentation screen.
Yep, all good.
Good?
Mm-hmm.
Okay, cool. Awesome. Welcome everybody again to our virtual tour. We wish that y'all were here on campus with us, although maybe not today because it's freezing in Fort Collins. But here's just a view of the foothills. So Fort Collins is kind of nestled right in the foothills of the Rocky Mountains, which is absolutely gorgeous. So normally for spring semester, it's very sunny. There's lots of people out on our intramural fields playing football, playing frisbee. There's lots of dogs around campus. So definitely a very community oriented atmosphere, which I absolutely love. And so up in the left corner, you can see some of that open space that we have here on campus. So again, that's where everyone will be out and about on the nice sunny days here in Colorado. And then in the bottom right, you can see an aerial view of our new stadium. So new football stadium was built, I think 4 years ago now, which is crazy. Super nice, very fun for the football games, even if our team might not be the best. But like I said, Fort Collins is beautiful, lots of trees, and CSU especially has a ton of open space. So nice to lay out, take a study break, sunbathe, whatever you like to do in your free time. So here's a view of our first engineering building. So this is the Walter Scott and Suzanne engineering building. And this was actually donated by Walter Scott Jr. himself. So he graduated from CSU in civil engineering. Then he donated about $54 million to CSU engineering to build this building, and then also to fund some undergraduate scholarships as well. So some of you may have been eligible for the Walter Scott undergraduate scholarship, which is awesome. And that's all thanks to him. And he really gave us this building just to expand lab space, classroom space, and really just make more opportunities for engineering students here at CSU. Cool. So right when you walk into this building, one of the first things you see is our Student Success Center. So this office is exactly what it sounds like, and it's here for your success as an engineering student at CSU. And so we're a little biased because we work out of this building, but it really does have some great resources just for you. You can have your resume reviewed by professionals or by industry members. You can do a mock interview, again, by professionals or industry members, and then they also host our engineering career fair. So at CSU, we have a career fair that's open to all of the students in the whole university, which is awesome. But what's nice is that there is one hosted once each semester, and it's just for engineering students. So this is really kind of a good way for you to network and for to look for internships and co-ops, which we can talk about later more. But it all comes out of this kind of office right here. And so they're definitely here to help you be successful with your time at CSU and as an engineering student. So yeah, just know that these resources are here for you to take advantage of.
So these are our design studios, and fun fact, one of my favorite things about moving online is the Engineering Success Center and this design studio are by a full flight of stairs upwards from each other. So I don't have to do this part of the tour out of breath or panting. But basically, these are design studios. These are all donated by Lockheed Martin. If you're unfamiliar with Lockheed Martin, they are a huge aerospace engineering company based out of Colorado. They do lots of things in defense and space propulsion. So these are all set up just like how the design studios at Lockheed Martin are set up, with a central table that's dedicated to collaboration with individual workspaces surrounding that area. And we can see that little black box on the back side of the computers. Those are our VCLs, or virtual classrooms, or sorry, virtual thin clients. And so those allow you to have your own personal server where once you're accepted into the engineering college, you get an engineering EID, where you can log into your own personal desktop and access a variety of files and applications. And so a lot of times on tour, we get asked if you need to bring a Mac or a PC to a university with you. And so it doesn't really matter, because with either platform, you can log into your own remote server from wherever you are. So I can wake up on a Saturday in my PJs and get to work on some of my engineering projects from my house, without ever having to walk outside. And so what's great about that is you have access to any of the engineering programs you might need. So as a mechanical engineer, I use a lot of computer-aided design here in-house at CSU. We use SolidWorks. Recently, I've been learning about finite element analysis, which is through Abacus. Basically, you take your SolidWorks part, you put it into Abacus, and then you can apply boundary conditions or forces and watch how it's going to deform. So hypothetically, if I design this pencil in SolidWorks and I could apply a force to bend it and have that be modeled on the computer program. Additionally, our coding that we use is Arduino. So just those little Arduino microcontrollers that you can get for like 20 bucks, and then MATLAB. And so all those licenses come with your CSU tuition. So there's no any extra fees when you get here for those licenses. In addition to the computer labs and the programs, wherever you see a computer lab, there's going to be a printer. About every semester, you get around $20 to $25 worth of printing credit, depending on how many credits you're taking that semester. And so I think a page of colored paper is about 3 cents. So $25, you're not ever going to run out, and it'll stack over towards, at the end of each semester, it'll roll over to the next semester. So some of my friends have about $70 worth of printing credits that they wish they could take out for food or something like that. And yeah, anything that I missed, Katie? So this is an example of one of our study rooms, and you can actually see those dreaded stairs that I'm talking about right there on the right. I'm in shape, I promise. I'm just from Texas, so this higher elevation. That's what I blame. Basically, this is one of our study group areas, and so that wall on the right is actually a whiteboard. What I love so much about engineering and CSU specifically is the collaborative nature. Unfortunately, the problem is always going to be smarter than you, so you really have to work in a team to figure out how to work on those problems and get the correct solution. And so having these areas where it's quiet and there's lots of spaces to collaborate and work with people is something that I've really appreciated here at CSU. So moving on to our biomedical engineering teaching lab, this is Biome 300, which is a junior level biomedical engineering teaching course. And if Katie, you want to go to the next slide. Thank you. So as you can see here, there's some of the projects that we're working on. I'll talk about those in a little bit. Basically, in this lab, it's a teaching lab based lecture. So in lecture, you're not learning about how to solve specific problems. You're learning about how to work on the theory to approach any problem. So when I took it, one of my problems was designing a EMG-based myoelectric prosthetic hand control. And so that was a lot of jargon. Basically, those little electrodes on the top left picture on our coworker Ananya, who's actually here today. Those were read by a device that detect the electrical impulses from your forearm muscle. And so as you flex your arm, it would pick those up. And then we had to develop a way to take that data, interpret it, filter it, and then analyze it through MATLAB into variable controls that would actuate a mechanical prosthetic hand. And so in lecture, we're not necessarily learning about how to do signal filtering, but we'll do things like how to read literature review, how to kind of scan through all that technical jargon of a lot of these academic papers, or how to figure out if this source is credible, or how to work in a team, how to set up group group scheduling. So things like Gantt charts, which is basically just a really fancy calendar that mechanical engineers use a lot. And so what I love about this lab is again, the collaborative nature of this, because in this lab, you get to work with the 3 partner majors. So here at CSU, we don't have a biomedical engineering major by itself. We actually partner it with 3 partnered majors. So it's going to be electrical, chemical and biological, or mechanical engineering. And so the reason we do that is we've heard from industry that biomedical engineering as a major is just way too broad. You can really do a lot of things with a biomedical engineering degree. So by having that partnered major, it allows our CSU engineering students to have that breadth of knowledge that you get from a biomedical engineering degree, with also that depth of knowledge that you get from that partnered major. So for example, as a mechanical engineer, I'd be working on things like prosthetics, or I know Stryker is a big biomedical company. They work on gurneys, and so, or scalpels or robotic surgery. So all that kind of stuff is something that you'd see in the mechanical engineering space. For someone like Katie, she might be working on drug delivery or cancer treatments, protein synthesis. I'm sure she could give you better examples of what chemical engineers do. But then for something like electrical, they may be working on something like X-rays or CAT scans, all those kinds of electrically or optically based medical device products. In this lab, I also like to talk about the research that we have on campus. So CSU is a tier 1 research facility, and I think it's in one of the top 3 universities in the US that is funded by the government that does not have an associated medical school. So basically, we receive a lot of funding for our research, and it's a really great way to dip your toes into the field that you're interested in. So through my cardiovascular biomechanics lab, I'm able to get a sense of whether or not I like lab work and just get my hand on a lot of different projects. And it's really just as easy as if you reach out to professors and say that you're interested in what they're studying. A lot of the times they're going to be willing to have you come into your lab, even as an undergraduate with no experience. I think this summer after my freshman year, I emailed 4 or 5 professors saying, hey, I really like what you're working on in your lab. I was wondering if you have any open positions for undergraduates. And I think almost all of them said, we'd love to have you come in and see if you're interested in what we're working on. And then I just decided to go with the cardiovascular biomechanics lab. And I've been working in that lab since freshman or sophomore year. I think that's it.
Awesome. So since this is a biomedical engineering tour and mechanical, we'll do a good overview of all of the 3 partnering majors for the biomedical engineering program. And then we'll also go pretty in depth with mechanical engineering and some of that aerospace concentration, since we have a few folks who are just interested in mechanical. So first we'll talk about chemical and biological. This is my partnering major, so of course I absolutely love it. And CSU was the first university to actually be ABET accredited in this program. And so ABET accreditation is something you should look for kind of regardless of where you go. If you're looking at engineering or anything kind of in that STEM field, you should look for this accreditation, just because it's the accreditation board for engineering and technology. So it really just ensures that you're going through a program that's going to prepare you well for industry, essentially. And so CSU was the first, which is pretty cool. And so oftentimes you'll see universities have chemical engineering as one degree, and then they might offer biological engineering as another one. But here at CSU, we combine those together in one 4-year program, 5 years if you're doing biomedical. But what's really cool is it's going to take all those chemical processes that you learn when you think of like oil and gas, for example, and take all of that kind of chemistry and now just apply it into a biological system. And so there's a really good overlap between those chemistry and biological kind of fundamentals. And that's kind of what this degree is all about. And so what you're looking at here in this picture is a hemodialysis machine. And so this machine is essentially functioning as a kidney. And so if an individual doesn't have a working kidney and they're not able to properly filter toxins out of their blood, you can hook them up to a hemodialysis machine, which will kind of extract all the toxins from their blood and then feed back that healthy blood back into their system. And so this machine just mimics that. We're not using blood. It's not very sterile to do just in a kind of this lab setting. So we're using water, and you can think of this water jug as that kidney. So what you're going to do is feed a stream of water that's kind of filled with nitrogen and oxygen. And so you're going to want to keep the oxygen in that blood, and you're going to want to filter out nitrogen because it's a toxin. And so what you'll do is actually get to learn about the different kind of membrane separations that you'll use, what kind of optimal conditions that needs to be ran at so that you can filter that nitrogen out but keep all the oxygen in there. And it's really neat. You're just going to be learning about all the different kind of flow rates, the temperatures, the pressures, everything that makes this machine work functionally and do its proper kind of filtration. And so with the chemical and biological lab, you'll get to work really hands-on with a lot of different techniques. So here's some students just working on various projects. You'll learn how to centrifuge, you'll learn how to pipette, you'll be working with different chemicals, different bacteria. And so one thing that I loved about this lab is getting to work with the bioreactors, which you can see in this bottom left corner. So one of the applications that you use with the bioreactors is you actually get to grow your own cells in these bioreactors and study how they grow over time. You get to mess with the different kind of conditions of the bioreactor to see what's gonna, help those cells flourish or what's going to kill them off essentially. So if you're working with like a bacteria, that's just good to know what kind of optimal conditions it needs to grow. One of the more kind of fun applications that you don't get to do as a chemical and biological engineer unless you take this as a technical elective, but you can actually ferment and brew your own beer in these bioreactors, which is really neat, just because yeast is a live kind of bacteria. So lots of hands-on application. And then if you're pairing this with biomedical engineering, some of the biggest applications are like Ethan was saying, drug delivery, cancer research, pharmaceuticals. And then if you're just majoring in chemical and biological, that opens it up to even more kind of areas. You could go into oil and gas, you could go into the food industry. So if you think about how yogurt is made and how they culture it with live bacteria, that's biological engineering. So lots of different areas you could go into, and having that biomedical engineering degree with it opens that up even more for you. And so I mentioned technical electives, so I'll just briefly talk about those. So every single engineering student at CSU has to take, I think, 4 different technical elective courses to graduate, 3 or 4. And so these are a chance for you to take a class in something that you don't know much about, so you can kind of branch out and learn more that you're just interested in, or you can use them as a way to really narrow down something you're interested in. So for example, I really want to go into the pharmaceutical industry, so I'm taking a pharmacology class as a technical elective, but you can really just use this to either narrow down and help you focus and become more specific in an area, or you can just learn about something that's of interest to you, kind of not as relevant.
All right, so this is our engineering building. And just before we get into this, before we transition away from biomedical engineering, the biomedical engineering program is a 5-year program. So if you guys were wondering what you miss out on by having that partnered major, I take the exact same classes and Katie takes the exact same classes as we would with our partnered major. So one of my roommates is just a mechanical engineering major, and I've taken all the same classes as him. So you're not really missing out on anything. We're just as qualified in those partnered major fields as our single major counterparts. We just have the additional year to tack on those extra technical electives and biomedical engineering focused classes. But moving on to our engineering building, this is kind of where the heart of, at least I like to say the heart of my engineering career is, just because this is where I go to the manufacturing lab as a mechanical engineer. And so this houses our civil engineering department, our mechanical engineering department, and our computer and electrical engineering department, and our environmental engineering department. All right, so this is the EMEC, or the Engineering Manufacturing Lab. This is probably my favorite place on campus. You take a class called Mech 200, which is Introduction into Manufacturing, where basically you're in a machine shop working. You go in for 3 hours a week into a lab where the lab assistant, or sorry, not the lab teacher, teaches you how to use all the different tools in the lab, and then you go in your free time to make a bunch of different parts. Katie, do you want to go into the next slide for me? Perfect. So on the right, or sorry, on the left, just there's a bunch of radius gauges. We call it the cage. You have to work a shift there, basically twice a semester, where you're checking in and out tools for the other students who are in the lab. On the right, you can see he is working on the vertical mill, putting a piece into the vices. And then on the left of the right picture, that silver box is our CNC, which stands for computer numerical control. Vertical mill. So you're able to use all these machines. So you go through a lathe, a vertical mill, a CNC machine. We actually have a CNC lathe now, which is a 4-axis machine as opposed to just XYZ. It has XYZ and then a third A axis, which is in line with the X-axis direction. And this really has just been my favorite lab just because it is so hands-on. I actually still have my piece that I made in lab next to me right now. So I have this clock that I made in the shop as one of my projects. And so everything you see here, other than this black box, which has the clock mechanism, was made from a raw piece of material. So this aluminum stand, this steel pencil holder, the brass pen holder, and this acrylic base plate all started with raw material. And so we learned the processes to take it down and to account for any manufacturing tolerances or errors in the machines that we're using to make those final products. Something I really loved about this lab, aside from just being so hands-on, was just how team-oriented, I guess it was. And these projects are solo, but so much of what you learn in here is learning from other students who have more experience. We use an oxyacetylene torch. We can get up to 1500 degrees Fahrenheit, and so that is a huge tank of basically flammable oxygen and flammable oxyacetylene. And I can't describe how scared I was to use it the first time, just because there's a lot of safety precautions and I had never touched something like that before. Before coming into this lab, the biggest thing I'd use is maybe like a handsaw to cut, I don't know, nothing, I guess. But and so I would have like 6 or 7 people who I've never met before, just making sure I'm putting all the pressure in right, I'm lighting it correctly, I'm heat treating all my metals correctly, to make sure I don't mess anything up. And so that kind of camaraderie that I got from this lab is really what cemented me in the mechanical engineering program, just because it really started feeling like a big family after that. Because after this lab, you're in there for hours of a week and you're meeting all these other new people who maybe you don't run into classes, but then you're just standing next to them on a vertical mill, ask them how they worked on their part, if they could help you out on your part. And I can't tell you how many people would come in during their free time and help me with my parts. I'd say, hey, I just saw that you finished, heat treating your metal tip. Would you mind showing me how you did that? They say, sure, I actually have class right now, but I can come back in like an hour, and they'd sit me through a whole 2-hour process just because they were interested in making sure I got my projects done. So really love this lab. And you can actually use it after you pass the class. So basically, once you're done with the class, you can get a pass where you can go in after hours. And so I was actually just there earlier today. Okay, so this is our idea to product lab. So this is additive manufacturing. The EMEC is a subtractive manufacturing. Basically, just subtractive is you take a block and you remove stuff. Additive is you start from nothing and you add stuff. And so this is a completely student run lab. I think the lab fee is about $12. And so we have 7 3D printers now, and so they're huge 3D printers. And actually, we just got one that can deposit water soluble filament. So if you guys have ever done any 3D printing, instead of having the supports that hold it up and having to peel those off, it'll print water soluble supports that once you dip it in water, the supports will dissolve away, so you don't have to do any of that post processing. We also have one that can print in a filament that has carbon fiber. So I've actually seen those being used for a prosthetic trial piece where it was being used as a injunction with our orthopedics lab here on campus. And so because it's a student run, you can actually get a job here if you would like, but all the students here are very familiar with the ins and outs of 3D printing. And I came into this lab with no experience 3D printing, not even seeing one before. And I feel pretty confident on basically anything that I need to 3D print I could do with the help with the people in this lab. So this is our materials lab. And so you'll hear this a lot at CSU. We really want our hands-on application. So this is a materials lab. This is Mech 331. I took this 2 semesters ago. And basically you go into the lab and you'll do stress analysis. So you'll take a piece, you'll pull it apart, you'll push it together, you'll twist it, and you'll see how the stress and strain curves, so basically how much force you can apply versus when it fails, make a bunch of different curves of different material properties and the hardness. Sorry, you'll basically look at a bunch of different materials and figure out the properties of how they react to different forces or heat treatments and how that affects the atomic properties of those materials. So in this lab, we want to take those principles that we're learning in lecture. So something like having a crystalline structure and seeing how those crystalline structures help with the material properties in deformation or strain analysis. You want to go to the next slide? Okay, so this is our Mechatronics Lab. This is Mech 307. This is a junior level class, so you take it in your 3rd year. Basically, if you ever done any robotics, that will definitely help you. I'm in this lab currently, and I've never touched a soldering kit or an Arduino before, and so what this lab does is help get you up to speed on anything robotic. And so you'll take all your engineering knowledge that you've learned. So you'll take a introduction into electronic circuits in your 2nd year, and then you'll take a bunch of design courses up until this course where you can design a robot. And then in this lab, they'll teach you how to wire it using your basis from your engineering electronics courses and basically make a project. And so there are 4 requirements. So it has to move, it has to be semi-autonomous. So once you give it a command, it'll do something automatically. It has to light up, it has to make a noise. And so you can kind of take this into any direction you want. Some of my favorite are, it's a whack-a-mole game, but they called Whack-A-Professor. And so what they did was they had some of those professors come into our idea to product lab, so our 3D printing lab. They scanned their faces, printed them, painted them, and then they made a whack-a-mole game that was basically just a professor's head that popped up and down. Fun fact, the only professor's head that actually went up and down was the professor of the mechatronics course. So that was a fun little jab at him. But another one is a self-leveling drink cart. So basically it was a drink cart that was on 2 wheels that would stand up like this, and then you could hold drinks up at the top. And so no matter how you kick it, knock it around, it would auto level itself on the 2 wheels, kind of like a Segway. And then you could actually there was a remote control where you could cart your drinks around through your house. And rumor has it that the professor of the mechatronics still uses that drink cart in his house today as a little party trick for when he has guests over. So this is the thermal fluids lab. I'm in this lab currently. And so Katie, if you want to go to the next slide, it shows a better picture of it, I think. Thank you. So this is where we test all the principles that we learned in our thermodynamics and our fluid mechanics lectures. And so again, trying to take that lecture aspect and bring it to a hands-on nature. What we've heard from industry is that a lot of our CSU engineers graduate with a really intuitive concept of what they've learned in lecture and how to apply it to the physical sense, because basically, especially in mechanical engineering, a lot of the classes you take are going to have an associated lab where you're learning about something in lecture and then you're applying it to a real world setting. So starting from the left here, this dark green machine is a water, I guess, like a wind tunnel, but just a water tunnel. And so that tests flow around an object you can put in it. And then to the right, that light blue one is with a big cylinder. That's a wind tunnel. So you'll see how air moves across an object. The yellow pipe is actually the lab that I'm working on this week. So it shoots high pressure oil down those tubes during different diameter of pipes, and then it tracks the pressure of it to determine laminar flow, so whether or not it flows smoothly or with turbulence. Then the next one is an open water pressure system, or open water pressure system, where it'll test things like dams and how that'll react with water or waves crashing against it. So you can think of something like that with the piers, and like San Francisco that go out into the beach. You'll put a model of the pier into that system, and then you'll track how the waves crash into it to determine whether or not you'll get any swells or any features that may wash up sand and unroot the posts in the ocean.
Cool. So now we'll just briefly touch on electrical engineering, which is the last partnering major that you can do with biomedical engineering. So electrical engineering is mostly focused on hardware. And so this is actually one department, electrical and computer engineering, but they're two separate degrees. So you can either get a major in electrical engineering or computer engineering, but only electrical engineering can be paired with biomedical, just because computer engineering doesn't make a lot of sense kind of in terms of the biomedical industry. And so electrical engineering is all on hardware, computer engineering is all of that software. And so I would say computer engineering is kind of a nice middle ground between electrical engineering and computer science, in the sense that you're still learning all of the software that you would in computer science, but now you're kind of learning how to design computers and apply that kind of physically. And so with electrical engineering, the best way to kind of decipher between that and mechanical engineering is through one of the examples that our mechanical engineers actually do as a project. And so Ethan might be able to talk about it a little better, but the mechanical engineers have to design a car that will follow essentially a piece of black tape on the ground and follow it pretty much down to every single turn. And that's kind of what they get graded on. So where the mechanical engineering students will design the car and like the motor and how it moves, the electrical engineering students design that sensor that goes into the car. So the sensor that will actually track how much light is coming in or reflecting off that black tape, so the car knows where the line is and how to track it essentially. And so some of the kind of applications of electrical engineering in the biomedical industry are basically your imaging system. So like CT scans, MRI scans. A lot of kids will go into robotic surgical tools as well, which is kind of a new and upcoming field. And I just lost my train of thought, but I think, yes, okay, it has to do with this. So this is a electrical engineering senior design project. So these students are partnering biomedical engineering with electrical, and what they're working on here is actually a MRI scan. And so MRIs currently are very expensive, and they take a very long time to get a high resolution image. And so one of the senior design projects that some of our fifth year students are working on is creating an MRI machine that's quicker, still has the same high resolution, and is cheaper. And this is kind of the design and prototype that they have for this project. And so with the senior design projects, if you're in biomedical engineering, then your senior design project is in your fifth year, and it's going to be something biomedical engineering related. Whereas if you just did a 4-year program in mechanical engineering, then it'd be your fourth year and it'd have to do with mechanical engineering. But what's cool is that regardless of the engineering discipline you choose, you have to do some kind of senior design capstone to graduate. And a lot of times these projects are sponsored by industry or by different companies. And so companies will come in with a problem with one of their devices or something like that, and put together a group of students to work on it for them, which is really neat because then you're getting hands-on experience that you can talk about once you're interviewing for jobs in industry. And it's also a good way to network and kind of get your foot in the door to a company that you might be interested in pursuing. And so then with those biomedical ones, it'll be something related in that industry. And your project could also just be sponsored by faculty. So Ethan talked about undergraduate research here at CSU. And a lot of times senior design projects will be something that a faculty member is working on in their research lab. So that's a good way also to get that hands-on research experience as well. Ethan, do you have anything to add about electrical? Cool.
No, I think you did a great job.
Okay, so now we'll just talk a little bit about office hours and advising. So office hours are great. Every single faculty member in the College of Engineering is actually, I think just in CSU period is required to have office hours. And so this is a time that they slot out in the week just to help you with homework or any questions that you might have regarding the class or the material. So definitely take advantage of these. I remember my first year, I didn't go to office hours that much just because I was a little intimidated by my professors. But your professors are here to help you. They're here for your success. I've had a couple professors who stayed after their office hours to help. I had one who FaceTimed his kid to say goodnight over the phone because he was still on campus helping all of us with the homework. And so the faculty is definitely great. They want you to succeed and do well, and they're here as a support system for you. And then, oh, sorry, a Zoom recording just finished, so it swiped my screen. But academic advising is also great. So once you come to CSU, if you come to CSU, then you'll be assigned a advisor specific for you. So if you're in the biomedical engineering program, then you'll have an advisor specific for biomedical engineering and then an advisor for your partnering degree. If you're just doing mechanical engineering, for example, then you have an advisor that's in the mechanical engineering department. And your advisors are going to help you not only create your schedule every semester, but they're kind of just there to make sure that you're doing okay, that you're managing your class schedule okay. If you are taking too many credits and you want to cut it down, they'll sit down with you and help you rearrange your schedule and figure out something that works best for you. And they're also there to help you in your success through your time here, but also after the fact. So I'm in my last year now and I'm really looking to get a full-time job here. And so my advisors are really helpful with that. They'll connect you with anyone they know in industry. A lot of the times they'll send weekly emails with like internships that pop up. So they're again just here as a resource for you, and definitely take advantage of that and use it as a time to figure out what's going to work best for you and your success throughout your college experience. Cool. So here's just a picture of some more of those design studios, but now this is in the engineering building that Ethan talked about. And so again, just a lot of study space, more computers for you that have all the engineering software. And what's cool about these two labs is they actually overlook like the thermofluidics lab that Ethan showed a couple slides back. So you can see right down here, there's some of the wind tunnels and the oils. And you can see students working on labs too, which is pretty cool. So definitely a pretty hardworking environment all around the engineering buildings. So with classrooms, we always get asked how big are the classrooms, because CSU is a big university. And so every engineering student has to take math classes, general chemistry, physics, and those classes tend to be a bit bigger. I think my biggest class was around 300 students. That was general chemistry in my first year. But even still, I got to know my professors pretty well, and I did that a lot through those office hours. And with those bigger classes like your chemistry and math and everything, you have to have a recitation as well. And so the recitations are a class that's kind of additional to it, and it's just a classroom of about 15 to 20 students, and it's usually taught by a teaching assistant for that course. And so that's a good time to get more kind of one-on-one time with your homework or whatever it might be. And then with engineering, it really depends. Mechanical engineering is our most popular and definitely our biggest department. And so they have bigger classes, but they also have more class sections, if that makes sense. So Ethan can probably say how many students he has around, but I know for me, My chemical and biological engineering classes were about 100 students. And then my biomedical and chemical and biological classes were only about 20 students. And kind of naturally, you'll see that number taper off as you get further in your degree, just as people kind of find something that works better for them, whatever the case might be. But I've never had an issue with the classroom size, and I've definitely still gotten to know my professors on a personal level in almost every class that I've had. Cool. And lastly, I'll just talk a little about our engineering residential learning community. So this is a residence hall that you can live in. I actually lived in this residence hall my first year. And so this picture right here is kind of just looking into our academic village. And so academic village is composed of an engineering residence hall, an honors residence hall. So if you're applying or accepted into the honors college, then you could live there. And then a third building, which is kind of just the overflow for those two. But specifically with the engineering residential learning community, I loved it just because I was surrounded by engineers all the time. I formed study groups probably in like my first week of college, which was awesome. And I actually, 3 out of the 4 of my roommates, I all met in this learning community my first year, and we still live together 4 years later. So it's a great environment, and it comes with a lot of resources and benefits. And so here you can see more of those design studios, but now this is on the first level of that residence hall. So more of the computers with all the software, there's tables to do homework, there's printers, everything that you'll need for that. And then it also has free tutoring and mentoring as well. And so the mentors are just students who are older in the degree that you might be studying, and they're really there to just help you transition into engineering and into college, and just to be someone that you can check in with. And then the tutoring is offered Sunday through Thursday, and there's tutoring in like physics, math, chemistry, biology, all of those kind of core curriculum classes. And then there's also tutoring that's specific to your engineering courses that you'll take your first and second year. And so you don't have to live within the learning community to take advantage of these resources either. Even if you live in a different residence hall across campus, you can still come use the tutoring, you can use these computers, the printing, everything that you want. And so here's just some pictures of what the inside of the engineering residence hall looks like. So it will just be you and one other person, kind of in like a suite style, and then you'll have your own private bathroom, so a sink, and then the bathrooms over here. So really nice. I loved it. And I think the best part was just forming kind of a community right off the bat, especially with people who were in similar classes, if not the same classes, who had the same workload as me. And that just made it really easy to transition and to keep up with the coursework. Awesome. So that about concludes the presentation portion. But if y'all have any questions, we'd be happy to answer that. You can either unmute yourself or you can send them in the chat. I know we didn't talk about aerospace, so if any of the students here are interested in aerospace and that concentration, want to know more about that, we can talk about that as well. But yeah, feel free to ask anything you'd like. It doesn't have to be related to academics. It could just be related to CSU in general. Yeah, we're happy to help. Cool. And I will send our ambassador email in the chat. So this is an email you can use to contact anyone on our student ambassador team. So if you'd like to talk with a current student that's studying the exact degree you want, talk about the coursework, whatever it might be, we're happy to connect you with that. So I'll send that real quick.
Hello, I have a question.
Yeah, of course.
Yeah, so if you start as like a biomedical with your subdiscipline being chemical, but let's say you get a year into it and you want to switch to mechanical, but you still want to finish within the 5 years. At what point are you still, after the first year, like in the first year, are most of the courses generic for all those 3 subdisciplines? And then second, third, fourth year are then more specialized? Or at what point, I guess, if you've done 2 years into the chemical part of biomedical, are you too late to hop over to mechanical without having to do an extra year or something?
Yeah, good question. So I would say the first year is probably where that switch would need to happen by the end of your first year. So in your first year, you're going to take introduction to biomedical engineering, and then you'll take an introduction to your partnering discipline. But a lot of your first year is going to be filled with that general chemistry, your physics, your calculus courses. So those ones are transferable regardless. But I'd say once you enter your second year, that's when you're starting to take classes really specific to your partnering discipline. So that would be where you'd fall behind of the 5 years if you were to switch after that point, if that makes sense.
Yeah, no, it does. Thanks.
Yep. And the introduction to biomedical engineering course that you take in your first or second semester at CSU is really broad, and it's a good overview kind of the whole field of biomedical engineering. And you do different kind of sections that are specific to what it could look like with your partnering major. So a lot of students after taking that intro course are like, okay, I'm in the right partnering major, or I think I'm more interested in this one. And that's when they tend to make the switch, just because you get that good overview right off the bat.
Okay, thank you.
Yep. Awesome. Ethan, do you have anything else you want to add?
Nothing. Sorry for missing the aerospace. Completely slipped my mind. When I started talking about mechanical, I'm not an aerospace concentration. I just kind of get into this zone where I tunnel vision and just think manufacturing because I love it. But basically, the aerospace program or aerospace concentration, it's a concentration because the team that developed the concentration is members who worked in the aerospace industry, so things like Ball Aerospace, Lockheed Martin, and when they were developing it, they found that mechanical engineering majors without I guess, as opposed to just aeronautical engineering majors, had a better depth of knowledge of the core engineering like curriculum. And so with aerospace, you'll do things like control or something like controls or heat propulsion labs. But you're kind of missing out on some of those more essential typically mechanical engineering majors. So something like dynamics of machines, 4-bar linkages, things like that. And so having that mechanical engineering background with that aerospace concentration helps you get that depth of knowledge, like we've been saying, for the dual degree major, for the partner major of biomedical engineering. But then again, applying it to aerospace. And I don't think that if you start in in mechanical, you can't move into aerospace. One of my best friends, she actually just got a position at Lockheed Martin, and she is a purely mechanical. She took a few aeronautics technical electives, and so wherever you start, as long as you're interested in where you want to end up, you can basically shift your focus and shift your studies to get you to where you want to go and better prepare yourself for those positions. Did I miss anything on that, Katie?
Nope, I think that's good. Yeah, and with the kind of figuring out your interest later on, that works really well with mechanical engineering, and that works really well if you're just doing a 4-year engineering program. It's a little trickier with biomedical. So as we just said, if you're in biomedical, it's better to figure out which partnering major you're interested in kind of by the end of that first year for sure, just to make sure you're not behind. But with just mechanical engineering or just chemical and biological, you can really use those technical electives in your last year to really kind of shape out exactly what you want to do with your career, which is nice. So it leaves a lot of room for you to kind of figure that out and explore your interests a little further. Awesome. Well, if there are any more questions, we can end a couple minutes earlier or a couple minutes early. But if y'all have any questions further, kind of after the fact, or if anything comes up, feel free to email us at the email I sent in the chat. Also, we have a kind of talk feature on our website throughout the week. So throughout Monday through Friday, if you go on the engineering website, there usually is like a little pop-up window that's like, ask us a question or whatever. So if anything just comes up, that's a quick way to reach us as well. Just because the emails, it might take a little bit longer, but definitely feel free to reach out. If you still want to talk further with a current student, all of us ambassadors have one-on-one sessions throughout the week. So if you go to our engineering website, just the same way you signed up for Exploration Week, you can sign up for a one-on-one appointment or a virtual tour, which will be pretty similar to what we did today. But that's a good way to ask questions as well if anything comes up. Awesome. Cool. Well, thank you everybody for joining us.
Thank you
We're
guys.
glad you could come see campus virtually. And we hope to see y'all in the fall.
All right. Thank you guys.
Ethan, you don't forget to stop the recording as well.
Yes.